Hey again. So in this part of the topic, we're going to dive into how the body recruits different muscle fibers during exercise, which this is all about how the nervous system picks and chooses which fibers to activate and when. It's super relevant when we talk about strength, endurance, and fatigue, even in rehab and athletic performance. So let's jump into how muscle fibers get recruited based on what we're doing. Alright, let's start with the basics, the motor unit. We mentioned about this earlier in the previous chapter, but let's just do some refresher, okay? A motor unit is simply a motor neuron and all the muscle fibers it connects to. When that neuron fires, all of the fibers is connected to contract, like a squat or responding to a command. Okay, now if you refer to the diagram here, you can see that not all fibers are the same. We've got three main types. We have type 1 or slow twitch fiber. These are endurance oriented. They use oxygen very efficiently and they don't fatigue easily and are great for low intensity, long duration work like jogging or walking. And then we have type 2A fibers, which are the kind of the middle ground per se. They're fast but still fairly fatigue resistant. They are good for moderate intensity activities like when in athletic, we are talking about 800 meters. And then we have type 2X, or some of the books mention it as type 2B. These are your power fibers. Okay, they produce a lot of force very quickly, but somehow they fatigue very fast. Perfect for things like sprinting or heavy lifting, where you need a burst of power in a very short amount of time. Each motor unit contains only one type of fiber, okay, and different units are used depending on the demand. Your body chooses which ones to activate depending on the intensity of what you're doing. Okay, so here's a follow-up on that same idea. You can refer to the illustration here. Okay, it shows how different motor units are made up of different type of fiber. Each motor unit sticks up to one fiber type. So a motor unit is either all type 1 or all type 2A or type 2X. And remember, when a motor unit is activated, all of its fiber contract. So when you need light effort like standing or walking, only those type 1 motor units get recruited. But if you're sprinting or lifting heavy, now the body starts pulling in those bigger, more powerful type 2 units. Okay, this layering of recruitment is what we'll look at next. Now this is one of the most important concepts, the Hahnemann size of principle. Basically, it says that the motor units are recruited from smallest to largest. Okay, that means from type 1 to type 2A to type 2X or type 2B. So your body always starts with the slow twitch, low force fiber first. Why? Because they are efficient and they don't burn a lot of energy. Now, if you refer to the diagram here, you can see this gradual increase. As intensity rises, your nervous system brings in more motor units, including the bigger, more powerful ones, right? This strategy helps you save energy during low intensity activities, and it also makes movement more controlled. But when intensity kicks up, like during a sprint or maximum lift, those larger high threshold units jumps in. Let's break it down a little bit more. Look at the chart here, right? You'll see how recruitment progresses depending on effort. Type 1 fibers are recruited first for light work, then type 2A gets added as you push harder. And finally, type 2X comes in when you are giving maximal effort. Okay, so this principle is really about smart energy use. Okay, our body avoids wasting high energy fibers on small tasks, but when you go all out, it is all hands on deck, and that's when those big powerful fibers join the party. It's one of the reasons why high intensity training feels so very draining, because you're using all available fiber types. Okay, so now let's apply this to real life movement. Okay, different activities use different fiber types, and you can see that in the examples shown here on the slide. Okay, for something like marathon, it's mostly type 1 fibers doing the work. Okay, long lasting, fatigue resistance, and very efficient. Activities like Middle distance running or team sports rely a lot on type 2A. Well, long lasting, they need a mix of endurance and speed. And then you have explosive high power actions like sprinting or Olympic lift, you know. That's where type 2X fibers are front and center. Refer to diagram, it shows how different types of activity rely on different fiber recruitment patterns. You know, this is super important when designing training programs because you want to train the right fibers to the demand of the sport. Okay, now let's talk about neural drive and red coding. Okay, here's a deeper look at the coordination I just mentioned. Okay, neural drive and red coding. I know it sounds very fancy, but here's the deal. It's only about how strong and how fast the brain sends signals to your muscles. Okay, so neural drive is basically the strength of the signal from your central nervous system. If you need more force, your brain sends a stronger message. Red coding is about frequency, you know, how quickly those signals are fired. The faster the signal, the stronger the contraction, right? When signals are sent more frequently, motor units fire more rapidly and force goes up. You know, this coordination between recruiting more motor units and firing them faster is how your body controls total force output. The cool thing is, this all happens automatically in the background every time you move. Okay, so here's a deeper look at the coordination I just mentioned. Okay, the diagram here shows both recruitment and firing rate, that's red coding, combined to generate different levels of spot. Okay, at low effort, just a few motor units are recruited and they fire very slowly. Okay, as the demand increase, more units are brought in and all of them start firing faster. That's how your body can scale up from light movement to full force action smoothly and efficiently. It's a pretty amazing system and it all shows how important the nervous system is in strength and performance, not just the muscles themselves. Okay, so what happened when fatigue kicks in? You know, so fatigue can be central from the brain or peripheral from the muscle itself. Either way, it affects how well your body can recruit and use its motor units. If you look at the diagram here, you'll see that type 2 fibers, especially the type 2X ones, fatigue very quickly. So as they start to wear out, your body might shift back to using more type 1 fibers if it can. Also, when you're fatigued, your body may try to bring in additional motor units, even ones that weren't originally recruited, just to keep you going. But somehow this isn't very efficient, you know, and performance usually drops as a result. So understanding how fatigue affects recruitment helps explain why techniques break down during intense or prolonged exercise. Alright, so to wrap it all up, what you should remember from this. Okay, first, motor unit recruitment is a graded process, meaning your body brings in more and bigger units as the demand increases. Okay, different fiber types have different purposes. Endurance versus power versus the in-betweens. You know, refer to the summary points here. They show how understanding recruitment helps design smarter training programs. Also, different sports rely on different types of fibers. A sprinter and a marathoner have very different recruitment patterns. And finally, fatigue changes how and which fibers are recruited, which directly affects your performance. Okay, all in all, it all ties back to how incredibly adaptive the body is, you know, always adjusting based on what you need. All right, and that's the end of this session on muscle fiber recruitment. Hopefully, this made the whole concept a bit easier to understand and more connected to real training and performance. Whether you're designing training programs or just trying to improve your own workouts, knowing how the body recruits muscle can really help you train smarter. Right? Thanks for watching. I'll see you on the next topic. Thank you.